All right, hello everybody. Today we're going to be doing partial derivative practice. So this isn't necessarily going to be me teaching, rather just practicing some problems with it. Hopefully you pick up on some things you're maybe lacking in. And I'm doing this all in one cut, so I might make mistakes too, and I apologize for the way that I'm breathing. I've been dealing with some allergies. All right, so here we go. Let's just jump right into it. So we're gonna go ahead and do the first one that I have saved down, and it's a pretty basic partial derivative. Okay, so for this one, we're just going to be taking the partial derivatives with respect to x and with respect to y. So let's go ahead and do with respect to x first. So first term, second term, third term, fourth term. Okay. So let's go ahead and get through these. So that first derivative that I see here, we get a 4x, and we treat this y here as a constant. So, yeah. Sorry, let me do the line tool actually. Yeah, oh yeah, that's way better. Okay. So this just remains as y3. Y to the third, sorry. So let's move on to the next one. We're going to get 6xy. And then for the next one, we're going to get 4x. And then for the last one, notice how there's no x at all anywhere. So that means that it just goes away. So, I mean, this gets treated as a constant. So, what happens when you take the derivative of, like, I don't know, a constant, it just goes to 0. So yeah, so that's the first partial derivative. Now let's do the second partial derivative, or the partial derivative with respect to y, actually. So for this one, I see that it's 6x squared and then y squared. And then here we're just going to end up with 3x squared, because the y will go away, right? And then for this middle one right here, there's no y, so that goes away. And then we get 6y, and then the 1 is kind of irrelevant, and partial derivative of a constant. Okay, so these are the first two, these are the first two answers. I mean, the partial derivative with respect to x and the partial derivative with respect to y for this problem. So, yeah, if you want to practice it again, just go back to the beginning and copy down the problem when it was fresh, I guess. So, off to example number 2. So, we have another partial derivative. Sorry about my breathing. I can't really breathe through my nose right now. Cosine y, e to the y, sine x. Okay, so this one too, we're also just going to be doing partial with respect to x and then partial with respect to y. So let's go ahead and do that. So partial with respect to x. Oh, by the way, feel free to pause the video for any of these problems and do them first, and then you can just check back with me. Again, I'm doing this all in one take. I'm not going to edit it or anything, so you kind of can just like go ahead and skip ahead. Sorry, I kind of don't want to go through the trouble of editing this. I don't know how long it's going to take. Okay. Regardless, I digress. Let's start with partial with respect to x. So this first part here, what I notice is that we only have one x term, and then we have a y, and then we have a y, and then we have an x. So for this first one, we only have one x, and that's with e to the x. And we know that the derivative of e to the x, so this is basically equivalent to, actually, no, let's do a different variable. Let's say it's, shoot, should that actually be? Anyway, all right. You know what, let's just do this. All right, just forget about the, all right, let's say we have e to the u, right? So this would be e to the u times the u prime. That's what the derivative of e to the u would be. So e to the x should just be e to the x because the derivative of x is 1. And then this is being multiplied by a cosine y. So there's a y variable in this. So there's no, it just gets treated as a constant. So you don't really do anything with it. Also, we won't do product rule here. There's no product rule. And there's no product rule here because we don't have x in both terms. We just have x in one. So you don't have to worry about that. And then for the next one, the e to the y is fine. And then this is being multiplied by sine x. And we know that the derivative of sine is cosine x. So this is our answer for the first partial derivative with respect to x. So that's fine. Now we're going to do partial derivative with respect to y. So we look back and this one's going to be, so the e to the x this time will be left alone. And then the cosine y will be changing. So it's actually going to be, the derivative of cosine is negative sine. So actually, what we're going to do is we're going to pull that negative sign to the front. And we're going to get sine y. Because it's supposed to be negative sine y, but I just moved it to the front just to make it look nicer. You can do that. Now for this next one, we have e to the y, and we know, based on the last example, that this is just going to be e to the y again, and it's just going to be times sine x. Sorry, I'm getting a little bit confused with this one being right on top, but we're focused on this one up here. So, to me, this looks good. So, we're all set with example number 2. And feel free to rewind and try these problems again, or pause, try them, whatever you prefer. So this is example number 3, and it's going to be, so in this case, z is equivalent to the function with the variables x and y. Okay, so I said I wasn't going to teach, but okay, this is actually kind of important. So let's just say we're taking the derivative with respect to x. So if we're taking the derivative with respect to x, notice that the x is in the exponent position, so this is going to be kind of weird. So for this one, you want to think of it like this. So this y is equivalent to like a constant. So let's just say that this y is 7 and then it's x right here. So in this case, to take the derivative of this, what you would do is you would have 7x multiplied by the natural log of the constant. So this guy right here. So for this problem, you'd be doing yx times the natural log of y. So, yeah, it's basically how you do that partial. Now, let's say you want to do the partial derivative with respect to y. Now, the y is down here. So, basically, for this one, how do I explain this one? So, for this example here, what we want to do is, so think of it like this. So x becomes like a constant. So x is like 7. I'm sorry I keep on using 7, but let's just say that x is 7. When you take the derivative of, let's say, y to the second, there shouldn't be an x, whatever. This would just be 2y, right? Because you take whatever's in the exponent place and you subtract 1. You like push it up front and then you subtract 1. So you kind of want to use the same logic here. So let's just forget about that. So let's say it's still x. So what we're going to do is bring x to the front, right? And then you subtract 1 from the x. And then from there, that is basically your answer. And just to speak on this point up here again, let's say that we're taking the derivative of, let's see, e to the x, right? Right? So for e to the x, obviously you can use chain rule, but you can also think of it like this. You can think of it like e to the x times ln e. Notice how we do like kind of the same thing when something's in the exponential place. And then this will just cancel. And then you end up with e to the x. Yeah, so that's just to kind of explain that result up there a little bit further. So this is how example number 3 works. Okay. Those look right. Yeah, I think those are good. All right. So now let's move on to example number 4. Okay. I don't know where my notes are. Oh, okay. So for example number 4, okay, so just to refresh our memories a little bit, cosine h, cosh, this is hyperbolic cosine. So the hyperbolic, like the identities are kind of easy. Well, for like the derivatives. So we all know that sine x, the derivative of that is cosine x. And the derivative of cosine x is negative sine x. And then the derivative of negative sine x is negative cosine x. And then the derivative of negative cosine x is sine x. So, you know, it goes back in full circle. Now, for sine, for sinh or sine h, hyperbolic sine, the derivative is cosine cosh, hyperbolic cosine. And then the derivative of that is sinh again. And then the derivative of that is cosh again. So they just keep on going back and forth. So just remember that for this problem. Okay. So partial g, right? Yeah, partial g. Yeah, okay, partial derivative of g with respect to x. Okay, so for this one, it's going to be a little bit different. Notice how x is present in both these terms that are being multiplied together. So we need to employ an old rule that we know. Now, people have a lot of different ways to memorize this. But the way I memorize it is like this. F prime g plus g prime f. And this is our product rule. Okay? So, since we know that this is... Oh, probably shouldn't have erased that, actually. Okay, so this is our product rule formula thing. So let's go ahead and define these guys. So f will be x squared. F prime would be 2x. G would be cosh xy, right? And then g prime would be sinh xy. But remember that we're doing the derivative with respect to x. So what's the derivative of just x by itself? It's just 1, right? So this will be multiplied by 1 over y, because like what we're doing right here is chain rule, right? You guys remember chain rule. So like sine 2x, like if we're taking like the derivative of this, for example, we get cosine 2x, but then we also need to multiply by that u on the inside. So let's just say it's like sine u, then you want to multiply by the derivative of the inside. So the derivative in this case would just be 2. So it would be 2 cosine 2x. So that's where we're getting this from. So this looks okay. All right. So now we just like put it all together. So 2x multiplied by g, which is cosh x over y, plus sinh x y times 1 over y. And then we multiply that by x squared. So this is our solution for this problem right here. I mean, it doesn't look great, but that's really all we can do with it. I don't really see a way that we can, is there, I mean, you could simplify this a little bit, obviously, like here, like you can put x squared over the y, and then you have like sinh xy, and then, anyway, all right. So let's just keep it simple, and we'll just say that this is our solution for partial of g with respect to x. So now let's just do partial g with respect to y. Okay. So notice here that we don't need to do product rule anymore because the y is only present in one term. So basically what this means here, so let's just go ahead and do this one. Okay, so when we do this one, we get x squared, that stays the same, and then the derivative of cosine h, cosh, is sinh sine h, hyperbolic sine. The inside stays the same, right? But then what do we do about the derivative? what is the derivative of this? Well, for this one, this is kind of awkward to take the derivative of as it is. So what you want to do here is we're going to bring the y to the top, and then we're just going to go ahead and take the derivative like normal. So then this ends up being negative x over y squared. So we're going to multiply this by negative x over y squared. Okay? I hope that makes sense. And if it doesn't, then I don't know, probably retake calc 1. Okay. So then simplifying this, we get this is our result. So we're just going to go ahead and highlight this. So that's our result for these problems. Okay? Looks good? Sounds good? All right, great. So let's go ahead and do something a little bit different. So this is our next example, and it's example number 5, I believe. I'm not sure, but it's okay. So w x cubed plus 3xy plus 2yz minus z squared. Okay, so in this case, w is going to be equal to f of x, y, z. Just keep that in mind, since, I don't know if you noticed, we have the new variable in here, which is z. So, of course, we're just going to take the partials, all the partials that we have here. Okay, so let's go ahead and take them. So let's start with partial derivative of w with respect to x. So first term right off the bat, 6x squared plus a 3y, and then the rest of it goes away because these don't have x. And remember, in partial derivative land, anything that isn't the variable that the derivative is being taken with respect to is just a constant. So yeah. Let's do the partial derivative of w with respect to y. So right off the bat, this first term gets eliminated. It's gone. Then we have 3x plus 2z, and then that's it. This last one gets eliminated too. Okay, then let's take the final partial, w with respect to z. So right off the bat, these first two terms get eliminated, and then we have 2y minus 2z. And I think everything here looks right. So we're done there. Okay, let's move on to our next example. We have up to 9 examples, and we're on example number 6. Okay, so number 6. Okay, so example number 6 is going to be a little bit weird, but just bear with me. Okay, so it's supposed to be a z, w. Okay, so for this one, you're probably like, wow, that's a lot of partial derivatives we're going to take. Nope, we're only going to be taking 2 of them. So, I mean, you can do it with the other ones, good luck. But we're just going to focus on these two. And I'm only going to give answers for these two. Okay. So we're going to do the partial derivative with respect to x for this one. So notice, do we need to do quotient rule at all? No, you don't. Because you only have x in one of the terms. And it's just in the one at the top. Actually, those are two separate ones. Whoops. You only have it in the one in the top. So you actually don't need to do anything fancy here, thankfully. Okay. So what's the derivative of x? It's just 1, right? So we just get w2 over y plus sine of zw. So that's our partial derivative of f of x. So that's a partial derivative of f with respect to x. So that was pretty easy. So let's do partial derivative with respect to w. Okay. So now I have another question for you guys. Do we do quotient rule this time? Yes, we do. So why? Because we have w and more than one term. Yeah, so let's go ahead and do this. So what we want to do is remember the formula, which is f prime g minus g prime f over g squared. Okay. So I'm going to just go ahead and fill this out quickly. I'm not really going to talk too much while doing it. So kind of, you can pause and try to do these on your own, but I kind of just want to get these answers out as quick as possible. Times 2 because we're doing it with respect to w. Okay, so now we just plug everything into the formula. So this is actually going to be kind of big. So, oh shoot. Okay, so altogether, this is going to be 2xw times y plus sine 2w minus 2 cosine 2w times x w squared over y plus sine 2w squared. Now, you may be thinking, should I go ahead and like cancel one of these out? Don't do that. Don't do that. Just leave the denominator alone. Okay. So I think we have a few more left after this one. Oh, I'm running out of space. I'm gonna have to move. Let me just have a reference line so I don't cross over on accident. Okay, so let's go ahead and do my problem number 7, which actually isn't mine. I actually took this from somebody else. Okay, so g of xy is going to be equal to x to the third y squared plus xy cubed minus 2x plus 3y plus 1. And I'm actually going to not evaluate this whole thing. I'm going to leave this one for you guys to do. Okay, so this is very, very simple. I will explain the concept behind it. So for this whole entire thing, we already know how to take the partial derivative of, equal of g. Sorry, well, you know what, let me just replace this with g actually. This is just going to make it easier. So we already know how to take the partial derivative of f with respect to x, how to take it with respect to y. For this one, when you see two x's, that means to just take it with respect to x again. So whatever is the result of this, n, you just take the partial derivative of x again with the same solution here with n. And you're going to apply that logic to all these. So take partial derivative with respect to y, then take the partial derivative with respect to y of that solution, and then take the partial derivative with respect to x, and then take the partial derivative with respect to y from that solution. So it's very simple to do it. Actually, you know what? I'll do one example of this just so you guys don't get confused. Let's do f of xy. All right, that's all I'm going to do. So partial with respect to x, this will end up being 3x squared, y squared plus y cubed minus 2. All right. And then now the partial of xy. So we already took the partial derivative with respect to x. Now we're going to take it with respect to y. So this ends up being 6x squared y, right, plus 3y squared. And that's the solution. So that's basically how you do these ones. Okay, now we're going to do a fun one. And we're almost done, actually. Okay. So we have f of xy equals x sine squared y plus y squared cosine x. And we're going to be taking these partial derivatives here. Okay. So how do we do this? Okay. So what we're going to do here first for these guys is we are going to take the partial derivative with respect to x first. So that's just going to give us sine squared y plus y squared negative sine x. All right, and now we need to take it again with respect to y. So this will end up being, so remember that sine squared y is equivalent to this. So we're going to apply that logic here. So we're going to move the 2 in the front, right? And then multiply it by the derivative, which is cosine y. Okay? So now we're going to do the next one. So we're going to get 2y sine x. So I'm only going to do this first part for this one. I'm only going to do this one. You guys can do that second one as a challenge problem. And I actually have one more for you guys to do. And this is just for you guys to do independently. You actually don't need me for this one. Okay. So for this one, I want you to find partial with respect to x first, then y, then z. Then for this one with y, then z, then x. Then for this one with f, with z, then y, then x. Then for this one with x, with y, and then z. Wait, did I just do the same one twice? I did. Okay, ignore this last one. So I just want you to go ahead and practice with these. And that's basically it for just some partial derivative crazy practice. Hope you guys enjoyed. Bye.